Students, this is ISI M.MATH 2017 subjective solution. So let P and Q be prime numbers. So P and Q are the prime numbers and n belongs to n such that P and it's not a structural part of this. So P given that in Q, so this is a number theory structure. So let's assume that the problem n of P is equal to 1. Okay. So let keep in this structure. So let this is a modulo pattern. So K be the order in n modulo. Okay, that is K greater than equal to 2 is the smallest positive integer for which P given in K minus 1. Now the form P of n Q minus 1. So we deduce that K by Q dot Q, this is a prime. So K equal to Q. So by Fermat's little theorem we can say P is of modulo P minus 1 to 1. Since Q is the order of n of modulo P, so it follows Q P minus 1. That's the answer. Next question. This is about group theory. Define all finite groups which have exactly 3 conjugacy classes. Okay, so let G be the group. So 3 conjugacy classes. So one conjugacy class is always the identity class. So this is the 1 CC. So let M and N be the sizes of the 2 conjugacy classes. So now conjugacy classes from partition of a group, we can say that 1 plus M plus N. So the size of the conjugacy class of G will be belongs to G equals and the index of a centralizer of G, that is it divides G. Okay, so obviously M, this one, and N, and further M divides this modulus G minus M, and N divides M plus N plus G minus N. So if we assume that M equal to N, let M equal to N. So M belongs to N plus 1, that is M equal to N equal to 1. So this is for G. So the only group of order 3 in the cyclic group is Z3. So it's an abelian group also. So it has exactly 3 conjugacy classes. So now if we assume the other part, that is M less than N, so then M plus N less than equal to N. So M, this is M plus 1, M2, N plus 1 minus M. So if M equal to 1, then N equal to 2, and this G equal to 4. So the only group of order 4 are in the clean 4 group, or the cyclic group of Z4. So both the abelian and thus have the 4 conjugacy classes. And if M equal to 2 and N equal to 3, then G equal to 6. There are 2 groups of order 6. So an abelian group of Z6 and a non-abelian group of S3. Non-abelian. So the permutations of 3 elements. So we check that the S3 are of 3 conjugacy classes will be as follows. Completely empty. 1 2, 1 3, 2 3. Last one is 1 2 3, 1 3 2. So the only finite group with 3 conjugacy classes are Z3 and S3.